right. Good evening, everyone. Welcome to the School of Design and Construction's lecture series. This lecture is sponsored by the SDC Lecture Committee as well as funding from the Department of Energy and is part of two new certificate programs in energy conscious construction. One of the programs is at the undergraduate level and the other is at the graduate level, and are being developed by faculty at the SDC, Mechanical Engineering, and the Extension Energy Program in Olympia. The certificates just launched this semester, and more courses are planned to be offered this summer. Brochures are available. I think I saw some floating around, but if you have any questions, please reach out to Omar Al-Asawi if you have any other questions about that. Now for the moment you've all been waiting for. Our lecture tonight will be delivered by our colleague, Steve Austin. Steve is a faculty member in the School of Design and Construction who has researched and lectured on the connection between design, construction, and climate issues for over 15 years. His professional experience includes work as an award-winning city and regional planner, an urban designer, a land use attorney, we won't hold that against you, a community,
We're not talking about law tonight.
yeah, all right, that's right. A community organizer, and as a university professor, basically one busy guy. Steve currently teaches landscape architecture, urban planning, and construction law here at WSU. And construction law is the topic he will cover in tonight's lecture, Net Zero Law in Washington, Implications by Design and Construction, for Design and Construction. Please join me in welcoming Steve.
Thank y'all very much. I appreciate y'all being here on a chilly night. Don't you just love it when a speaker comes out and says, we got a lot to do, so we're going to get started. We're going to cover a lot of ground. If I'm not making any sense about anything, don't hesitate to stop me, because I will be rolling through this pretty quickly. What we're talking about tonight are two things. One is the new law in Washington that requires the ending of greenhouse gas emissions within the next 27 years, and then the implications of this law for design and construction. Spoiler alert, right now I'm going to talk about it right off the top. If this law remains in effect until 2050, which will be the middle part of your practicing years, a lot of the students, if it remains in effect, and it may not, because it's going to bring some challenges to all of us, economically and otherwise. If it remains in effect, there'll be fundamental things that we will need to reckon with. We as designers and constructors will have much less materials to work with, we'll have changed construction methods, and much less energy overall. At the same time, the climate crisis will be challenging our ability to adapt. Complying with this law that is in effect right now will demand that we have a willingness to unlearn emission-laden work right off the bat. We'll need creative imaginations for new design and construction practices and a commitment to global leadership. A lot of folks that'll see this will be going, this can't be right. There has to be some way to keep everything the same as what we've been doing over the last 100 years. And a lot of people will be like, right, isn't that the case? Well, I'm going to give you some uncomfortable truths as I see them for our future going forward. So tonight the presentation will be broken up into three parts. We'll talk about the climate crisis that's spurred all of this. We'll talk about the new laws, and we'll talk about what I see as the implications of these laws for design and construction. So we'll begin with the climate crisis because that's the whole point of talking about this. That's why these laws have been enacted. And if you don't follow the climate crisis on almost literally a daily basis, you have no idea how bad it is. It's getting hotter, faster, and it's worse than anticipated. The last 8 years have been the hottest years on record. The average temperature on the planet now is 2 degrees Fahrenheit above the 20th century average, and this is accelerating. The UN issued a report about 18 months ago that said it's code red for humanity. It's worse than we thought. Michael Mann is a climate scientist who said Models are underestimating the impacts that we're already seeing. Climate scientist Andrew Dessler said it looks like it's going to be worse than we thought. And last year, the UN Secretary General said we are on the verge of the abyss. This is really happening right now. Just to kind of take a step back and look at the causes, we are creating a greenhouse effect by primarily through our use of fossil fuels, which is allowing the planet to trap heat that comes in from the sun. Heat comes in, CO2 prevents it from getting back out. We're heating the planet. There are three primary causes. One is industrial agriculture. When you look at this scene, you begin to realize that all that stuff that looks like dirt is actually CO2, and every time a tractor goes by, it's releasing into the atmosphere. It's being caused by deforestation. That's CO2, if you want to look at it that way, in those trees. Those trees get killed and burned, CO2 into the atmosphere. But primarily, the cause of this is from our burning of fossil fuels in the industrial economy. What we're seeing is something that humans as a species have never had to reckon with. For 300,000 years or so, CO2 has never gotten above that one line, and within an eye blink geologically, we've shot well above it. And what's happening is we're creating an evolutionary experience that we have no idea how to deal with. So let's start looking at the effects. We'll start with heat because that's the primary driver of all of this. I'll introduce a term that you'll hear more and more that's called a heat dome. We had one in the Pacific Northwest in July of 2021 where we saw a record just obliterated. And this was also a mass casualty event with 800 people having died from this excessive heat. So we as designers have to become familiar with the concept of a heat dome. That is, heat that comes and persists over an area for a certain amount of time. So let's look back at some kind of heat-related issues over the last year. Argentina, record-setting heat in their summer last January. In March of 2022, what scientists are saying, unprecedented heat. Scientists are astonished by what's happening at both poles at the same time. In April of 2022, Pakistan and India living in hell, unprecedented temperatures in April. In July of last year, the United Kingdom had their hottest day on record, which was a day of 105 degrees, absolutely obliterated their records up to that point. The heat had dried out the countryside and surrounding London, and it caused the busiest day in firefighting since the Second World War. At the same time, Japan, worst heat wave since records began. For the entire summer last year, Europe had its hottest summer on record. That was a record that they broke from the previous year. China, the most severe heat wave ever recorded in the world last summer. In the United States last September, a heat wave that no one had ever seen before. This month, the year began in Europe with an unprecedented winter heat wave. In the United States, bewildering winter warmth this month. And now, as we begin to move into the year, we're seeing that we're in an El Nino year now, which will cause even hotter temperatures, potentially off the chart. So the heat is happening, it's freaking scientists out, and it looks like it's going to get worse this year. All of that heat dries out the environment. So for example, and I don't know that this has ever happened, maybe it has, I haven't seen that it did. A lot of the major rivers in the world dried up last summer. The Yangtze, August of 2022. The Rhine River, August of 22. Completely around the world from China. And then here in the United States, the Mississippi River had record low water levels. So now we're seeing what the heat is doing to some of the things that we need for, our economy certainly, and our life support systems in terms of rivers drying up. But at the same time, a hotter atmosphere holds more moisture. So when it rains, it's going to rain a lot. Let me introduce another term that you're going to hear much more about as we move forward. That's called rain bomb. When it rains, it's going to rain a lot. Here in the Northwest, we saw that in the autumn and early winter of 2021. Record rainfalls, flooding places. Some of y'all may have lived through that, or your family had. So that's happened here. We've had a heat dome and a rain bomb in the same year in the Pacific Northwest. A year ago, historic downpours in Brazil. April a year ago, deadliest storm on record. Last summer, in the period of a month, the United States had 5 thousand-year floods in 4 weeks. And what scientists are saying is we've got to begin, understanding what it means to be a 1,000-year flood. That does a lot for us, of those of us who deal with stormwater infrastructure. What are we going to do if we're planning on these kind of future events? Last summer and through September, the worst floods in Pakistan's history, a third of the country, 30 million plus people displaced. That's still an ongoing catastrophe. This month, Western Australia's worst floods ever. California rain, one of the most deadliest disasters in their history. Some of you, again, may have had family. On Friday, just this past Friday in Auckland, New Zealand, they got 4 months of rain in 15 hours. That's going to be a disaster that city is going to have to deal with for several years. And it's not over. It's still raining there. That's a rain bomb. So if we begin to look at what the consequences of all this mean is, first and foremost, I think it's a food crisis. We've got heat domes, we've got rain bombs. We need a stable climate to grow the food that we eat. And right now, our climate is no longer stable. Last year was a year of record hunger. And then so what will happen as we move to the middle part of the century is that there will be 1 billion or more people who can no longer live where they're currently living because it's too wet or it's too dry or the food won't be there. So now we're talking about a human crisis of unimaginable proportions. And so ultimately, that's why we're talking about this. This is about humanity. So if we're talking about all of these things, we've got to realize that climate change is a deliberate human rights violation. We're doing this on purpose. This is not just some weird thing that the planet is doing. We're like, well, what's happening? We're doing this on purpose. So it's vital as we understand about this moving forward that we're talking about some things, but ultimately we're talking about justice. That's why we're doing this. So if we begin to look to the future, we know that 7 years ago, 196 countries on the planet came together to agree to keep temperatures below 2 degrees Celsius overall, and ideally 1.5 degrees Celsius from earlier averages. We're trying to limit the amount that the planet is going to heat up. That was 7 years ago. Oops, we're blowing through that really quickly. We're not going to be able to keep warming below 1.5 degrees Celsius. Why aren't we going to do that? Because we've done nothing about it in 7 years. The only thing in there's a little dip in that chart. That's the pandemic. The pandemic cut into our emissions, and then what did we do when the pandemic was over, which is not over? We went right back to our polluting ways. We did nothing in 7 years meaningful to address the climate crisis. So we know what we have to do. We have to face rapid emission cuts, or we have to have rapid emission cuts, or we face catastrophic consequences. And at the same time, look at some of the dates on this. It's September of 2021, The next day, the United Nations said, we're not going to not only do any cuts, we're going to, globally, and I say we, and I'm using that very loosely, as a civilization, we are going to continue to increase emissions by as much as 16% through the rest of this decade. So we've got to take a step back and we say, look, we know what we're facing. The United Nations is clear. We've got to end using fossil fuels. This says immediately. I don't know of any country in the world that's talking about immediately. We're always kind of pushing it off. But that's where we come into the Washington laws. That's what we're trying to do with the laws here in Washington, is do our part to avoid that future that is being portrayed in front of us. So we begin to talk about the climate legislation. If you haven't been paying attention, and really, to be honest, who pays attention to climate legislation, right? But Washington now has the most ambitious and most comprehensive set of energy and climate-related laws of any U.S. state. So we in Washington right now are in the leadership position in the United States. The centerpiece of these laws is called the Climate Commitment Act, the CCA. And that's what we're going to talk about primarily. What the CCA does is it says within 27 years, the state of Washington and its economy will pollute no more than 5 million tons of CO2 a year, and we're going to balance that out. I'll talk about net zero in a second. But basically, this is legally ending fossil fuels. Very few countries have done this. No other U.S. state have done this, and this is going to have very profound consequences. This is the most important climate legislation passed in the Western Hemisphere. This will be a model for the country and the world. That's us. If we're going to get it right, that's us in this room tonight. Governor Inslee says this is a way to move forward economically as well as in terms of justice. So we're linking the economics of this as well as trying to center justice in our work. Because as I said, that's really ultimately what it's about. When I say net zero, let me give you a little cartoon and explain what that means. Net zero means you put some greenhouse gas emissions, GHG emissions, into the atmosphere, but at the very same time, you take some actions to pull those out of the atmosphere. So that the ultimate result is the atmosphere has no more new emissions. So we go up and we go down at the same time, but here's the catch. We love greenhouse gas emissions, but right now we can't continue along that path because there's no way to bring them down immediately. And I'll talk about what some of those possibilities are. So this is going to be a very small equation. We're going to put some up, we're going to take some down, but it's not going to be very much. So ultimately what it means is we're ending greenhouse gas emissions in the state of Washington. So if we go back to that chart, we can look at it and say, all right, we've got 5 million tons of pollution that we can put into the atmosphere. At the same time, we've got to take 5 million tons out. And you think, well, that's cool. What is that going to be? What kind of machine does that? Well, there's not a machine that's been invented that does that. There is a piece of technology, though, which is a tree. A tree can take out carbon dioxide, but it takes it slowly. So if already, and we'll talk a little bit more about the technology, but if you're thinking, well, we'll just invent this machine and we'll pull out CO2. We're talking about CO2 at 420 parts per million. It's in the room with us, but can you imagine a machine trying to pull out 420 parts out of every million molecules in the atmosphere? It's going to be really tough. So here's the scale of the challenge, and I'm going to come back to this when we talk about the implications. Where does our energy come from that we use in Washington State? 4% of it comes from wind and solar. 4% of it comes from burning biomass, which is primarily wood. 8% comes from nuclear power. 15% comes from hydropower, the dams that you may have seen around the state. And 69% of our current energy comes from fossil fuels. Well, we've just seen that the law says that has to end. Where does that 69% come from in the future if we can't burn stuff? Another way to look at the scale of the challenge, when you break it down as to what the most polluting activities that we have are, transportation is far and away the largest polluter, but we have industrial processes, for example, that's making steel and cement for concrete. We heat our buildings. We generate electricity. All of those things are 100 million tons of pollution in 2018, and now they've got to go in 27 years to no more than 5 million tons. How's that going to happen? We don't really know yet, right? Because we've still got to figure out how we're going to take it down too. So, I'm going to go through some of the climate laws until we're going to focus primarily on the Climate Commitment Act. Washington's got a lot of new climate laws over the last couple of years. One is that electricity has to be made from completely emission-free sources by the year 2045. There's a Clean Building Act, which applies to large buildings in terms of their energy uses and the like. New energy efficiency standards for those kinds of buildings. We know that we need to electrify transport, so Washington's got a whole bunch of new laws relative to electric transport, primarily to electrify buses and ferries. This is a law that a lot of people hadn't heard of yet. In the year 2035, 12 years from now, there will be no new fossil fueled powered cars and light trucks, which is the trucks that we see, available for sale in Washington. That's pretty shocking, right? They're taking away our cars. We're working on, this is one of the specific laws that came out of this, we're working on slashing our emissions. We're eliminating hydrofluorocarbons that are primarily used for refrigerants and air conditioning. Those are greenhouse gases that are really powerful, even though there's not very many of them, so we're going to eliminate those. Here's one thing I don't think is really that ambitious. We're giving ourselves 15 years, essentially, to try to bring down the emission content of the fuels that we put into our cars. So we're not really pushing that because we understand how important our cars are to us, right? But really excitingly, all of this is within an environmental justice set of laws that will reduce environmental and health disparities in pollution-burdened communities and center justice in everything that we're trying to do. So those are kind of that suite of laws that complement the biggie, which is the Climate Commitment Act, which is net zero by the year 2050. So what is this ultimately about? It's about how much can you pollute and how much will it cost you? So that's kind of the ultimate, nutshell that we're talking about. But here's an overview of the Climate Commitment Act. It began 30 days ago. So this is a 30-day-old law, old law now. And quite simply, it's called cap and invest. That means you cap all the pollution at some level, and you charge people for the right to pollute, and you invest that money in certain things that we'll talk about. It remains in effect until or unless it's rescinded, but it remains in effect until Washington reaches net zero around 2050. This law applies to about 100 entities in the state that emit more than 25,000 tons of pollution every year. That's about 75% of current emissions. It covers entities such as industrial sources, which is steel making and cement, glass making, plastics. It covers electricity generation. It covers gasoline suppliers. People say, well, is this going to make my gas cost more? Yeah, It's going to. Because eventually we're going to eliminate gasoline. You have less of something that's going to cost more, right? What the 27-year time frame of this law is designed to do is to give all of these industries enough time to figure out how to survive the end of fossil fuels. So we're betting that in 27 years, all of these polluters will figure out another way to do everything that they do without pollution. If you don't comply, it could get very expensive, fines up to $10,000 a day. Significantly, there are some exemptions to this law. Aviation fuels are not included. Shipping fuels are not included. Farm-related fuels are not included. And biofuels are not included. This is the stuff that we burn that we just can't give it up yet. We got Boeing, we got shipping on the coast. If we do this, what will happen to some of these industries? So we're going to exclude those at least for a while. We don't know for how long. So that's a very brief overview of the law. There is a special category, and that relates to us as designers and constructors of these kinds of polluting industries that are called emissions-intensive, trade-exposed. That means we got a lot of heavy polluters that if we crack down on right now, where are they going to go? They're going to go to Oregon. They're going to go to Idaho. They'll just leave. So we're going to try to give them the ability to ride it out here. So this is paper and pulp and cement and computer manufacturing. We're going to try to keep them in Washington. We're going to give them free pollution allowances. So they won't have to pay for the right to pollute, but they will have to play by the rules of the game that they will have to end their polluting by the year 2050. This is going to be hard when we talk about decarbonization, architecture, and construction, because it's this sort of stuff that's really hard to deal with. So how much can we pollute? How much will it cost? The government is going to deal with this by creating a set of allowances to pollute, and they're going to have an auction for the private enterprises to fight over how much these things are going to cost. Hey, I really want this. I'm a polluter. That's going to drive the price up theoretically, right? So this is the overall chart that shows emissions declining. I mean, just really, this is the whole lecture right here. But let's talk about how that works, and we'll look at a shorter time frame. This is through 2040. We've got our emissions-intensive, trade-exposed cement and steel. They get free allowances to continue to pollute, and they don't have to really rapidly decline their polluting until the year 2040-ish or the late 2030s, but they still have to too. Power is that way too. Electricity, we don't want people's bills going up, so we give free pollution allowances to power, but they still have to decline. There's a small category in here, and this is really good, about offsets, because too often a polluting company will say, I'm going to go out and protect 100 acres of forest so I can still continue to pollute. Washington doesn't allow that. If you want to use an offset, that's going to take away some more polluting allowances. So we're trying to get at the real thing, which is ending the emissions and not playing a shell game of like, well, I've preserved some trees out there in the forest and I can continue to pollute. So Washington has a really good offset policy. And then all the other polluters have to pay for the right to pollute. That's where the money comes from, that we can do some of these other things. So here's kind of a cartoon of how that may work. The Department of Ecology says, all right, here's the number of allowances that we can have for each year. They're going to set that next month, and then it'll decline for the next 27 years. If you're a polluting industry, you need those allowances now, so you buy them at an auction from the Department of Ecology, and that gives you the right to pollute within the cap that you bought. One of the cool things is if you're a polluter, but you don't use all of your cap, you have some leftover allowances, you can look at another polluting industry that's really blowing over their cap, and you could sell your allowances to them. So in one snapshot, you can see that you're buying the right to pollute from the government, but then there's a secondary market where if you're a good polluter, not using all of your allowances, you can sell the right to pollute to some other entity or organization. But at some point, we know this law says there is no more pollution by the year 2050. So this program will phase itself out over time. So let's talk about where the money goes. Right now, the idea is that we're going to take the money that we get from this and we're going to put it into climate mitigation and adaptation. The state estimates that we'll see more than $8 billion from this scheme, $500 to $600 million a year, and that money is going to go to primarily helping us figure out how to decarbonize transportation. We are carbon junkies in our transportation policies. We saw that was 45% of all of our emissions. We've got to figure out a way to decarbonize that. There'll be another big chunk to help us adapt to heat domes and rain bombs and sea level rise. And then there'll be another big chunk about mitigating climate impact on ecosystems and using ecosystems to help us sequester carbon. That's going to be huge. And then finally, I mentioned this previously, there's a big component of environmental justice in this law so that we're going to ensure that air pollution is, in a sense, it has been burdening communities based on class and race, and we're going to try to undo that. There's an Environmental Justice Council that will provide oversight on all of this revenue. All the investments with this money will be targeted, or at least 35% to overburdened communities. 40% is the ideal target. 10% of all of that money to projects sponsored by tribes. And it ensures that tribes have a voice in all of these spending policies that affect tribal lands, so they have a firm seat at the table. So that is the law. Now we got to start talking about what the hell does this mean for design and construction. So I think we're all beginning this from scratch because there's never been a law like this, certainly in Washington State. What does it mean? Here's what I think it means. I think it means we'll have a lot less energy to work with, that decarbonization will be extremely difficult for materials and construction. Decarbonization alone isn't enough. We've got to pull this CO2 out of the air with what we do. And then obviously education has to adapt. How are we training the future folks who are going to deal with this? So the elephant in the conversation is there's going to be a lot less energy. This is the unpleasant reality because we all just assume, well, it'll be great, it'll be fine, we won't have to make any fundamental changes. Let's go back to this chart. Where does that 70% come from? Are we going to put wind and solar all across every available landscape in Washington State? That's likely. We could see the industrial renewable energy complex putting solar and wind power everywhere. Is that a good idea? Well, we're energy junkies, we need it. But nobody really has thought this through. We're not going to want to do a whole lot more burning of biomass. I'm not a nuclear fan, but even if we were, how much more nuclear could we do in 27 years than we already have? Hydro, we've dammed every possible river in the state for hydroelectricity. The math doesn't add up. We're going to have less energy in the year 2050 than we do have today. That is an unpleasant and unpopular reality because that's going to force some fundamental changes on us as a society, let alone as design and construction. And it's right there in front of us. Where is it going to come from? So we move on, though, we're going to have less energy. Decarbonization is going to be extremely difficult. This professor in Liverpool says we need to ask of everything that we do this fundamental question: how can this be decarbonized? And be governed by the answer, whether it requires regulation, restraint, technical change, or lifestyle adaptation. This is unpopular because we don't want restraint. That means we don't get to do what we want to do. We certainly don't like lifestyle adaptation. We like what we got now. And this goes to design as well. We like the way we're doing things now. So let's talk about what decarbonization means real quick. It means eliminating carbon emissions from materials, transportation, and construction. That's embodied carbon. We've got to eliminate that. And then we've got to eliminate from the operation of the things that we have, the maintenance of the things that we have, and the end of life cycle for the things that we create. No more carbon emissions from any of those things. How do we do that? How do we do that? Well, we got to figure it out, right? Because right now, all of the cool stuff that we do, cement and steel primarily, but machinery and plastic and carpet, it's just all emissions. We've never cared before what all the emissions we're adding up to, and now we have to, because the law tells us that we have to go to zero. So we've got to eliminate embodied carbon for sure, and all of the things that we do as designers and constructors has to be basically at zero emissions in 27 years. It's going to be difficult because the heavy industry that we use to create our materials is very carbon intensive, that generate high emissions. We need heat to create cement and steel. That heat comes not from electricity, which is turning on these lights, but from fire that's generated by fossil fuels. So what do we do about that? A term that you're going to hear more and more of as we move forward is hard to abate. That means we really like those materials, and man, is it going to be hard to try to make them without emissions. It's almost like it's going to be impossible. But we call it hard to abate right now as opposed to impossible to abate. It's not simply using cleaner fuels and improving efficiency. Those are going to be important. What it means is technical and transformational, transforming production systems, infrastructure, technologies. And we've got to do all of those things in 27 years. Can we do it? Well, they're telling us, the state lawmakers are telling us we've got to find a way to do this. There are scientists at the University of Cambridge in the UK who have published a report to help us deal with these decarbonization challenges called Absolute Zero. The premise of this report is we can't wait to know if we're going to figure it out by the year 2050. We just got to go ahead now and deal with the realities as they come up. The realities are that everything that we do has to be electrified: transportation, buildings, machinery, industrial processes. And that many materials will be reduced: steel production, ceramics, glass, other types of materials. Because we can't really make a whole lot of that stuff without emissions. And some things may have to absolutely not be used, like cement and creating new steel or plastics. That freaks people out. What are we going to do? Cement is the second most used thing on the planet besides water. Everything that architects and landscape architects and constructors involve cement, and now we may not be able to use any of it. If we curtail fossil fuel emissions, that's going to curtail air transport and cargo shipping and heavy machinery and long-distance trucking. So the reality is out there. Do we want to listen to it at this point? Those very same engineers are trying to figure this out. What can we do for cement, certainly? Their thing is, let's recycle building materials, and we can reuse some of that. So as buildings are taken out of service, we can reuse that material. But they admit that it's a scale problem. We're not going to be able to scale anywhere near the amount of cement that we're currently using doing it this way. Those same scientists are looking at green steel. Green steel is simply using hydrogen to create the fire that makes steel happen. Well, you could do that, but there's not any current green steel plants in operation anywhere in the world. The problem is that this takes an enormous amount of electricity to create the hydrogen that we use to burn to create the steel. For example, in Sweden, if they were to do this on an industrial scale, it would take half of their electricity needs just to make the steel. Price goes up no matter what. So a lot of people are saying, well, we got to figure out different ways to do it. We'll use hydrogen or whatever. Well, right now at least, not a solution. Another solution that may happen but is not at scale right now is using a technology to suck that carbon out of the air. Right now, there is no technology to do this at the scale that we need. So, less energy, decarbonization is going to be hard, but that alone isn't enough. We've got to take all of this excess CO2 and bring it and put it back in the ground. That's called drawdown. And the idea is that we want to take this CO2 and sequester it, put it back underground. That's what this is about. That's what net zero is about, is sequestering, as an example. There's a new report that just came out from the University of Oxford in the UK that says, yeah, we need to do net zero, but we also need to suck carbon out of the air, and we need to increase what we're doing now by a factor of 1,300. So we're really not doing anything. We need to do 1,300 times of whatever it is that we're doing now. That tells you the scale of this challenge. Here's an issue. 1 ton of concrete takes 1 tree to grow for 50 years, and over 50 years it'll sequester the amount of CO2 emissions in that ton of concrete. And the reality is that we're just using concrete like it's water, right? We can't plant enough trees to offset that. So we got to find other ways too. We got to plant trees. I'm not saying we can't plant trees. We got to find ways to use buildings as an example to sequester material. There's some great, new technologies emerging of hemp and straw and seaweed, compressed earth and wood. Mass timber is a big deal, but if we try to use timber to build all of the buildings that we're building now, we're going to run out of timber. Timber is important, but I worry about the idea of mass in that. So we begin to bring in, to a close, we could talk about what does all this mean for residential typologies in Washington State? Well, let's look at the future during this law that we're operating under. We've got 7.7 million people now. By 2050, we're going to add 2 million more people over the next 27 years. That's at a current persons per household of 2.5 people per household. We would need 780,000 new units, 29,000 a year, 80 units a day. So if we're going to house all of these new people, my question is, do we have enough energy and materials to do it all from scratch? Are we going to build everything new? I don't think so. So what do we mean? What do we do with that? Well, the greenest building is the one that exists, and we know that buildings are big greenhouse gas emitters. So we've got to find housing that already exists. So I think policy change is the most important thing that we can do. And here as an urban planner, I would add that we need to allow single occupancy units again in a way that we don't. This is illegal in most zoning codes. A room can be a home. Up until the middle of the 1950s in this country, almost everybody was either a boarder or a landlord in a boarding house because there wasn't enough housing at the time built new. We've got to maybe look back to history to find out how we can let this happen again. There's no emissions associated with this kind of housing. Here's another thing I get really excited about is finding housing everywhere. This is in Amsterdam, an old bank that now is housing. So we've got to find ways to allow this to happen. That would be illegal under most zoning codes. Right now in Washington, the legislators in Olympia are saying we need to abolish single-family zoning in this state and allow new housing everywhere. I don't know that this is going to pass because our cars are number one and our single-family zoning is number two in the way that we like to think about the American dream. But at least this is being talked about, that we've got a housing crisis. We've got to allow housing everywhere. And if we're going to build new housing, certainly it needs to be net zero materials, passive house standards, climate adaptive to heat and to rain and to wildfire smoke. We know we've got new climate conditions that we've got to deal with as we design these new residential places. Luckily, we've got this wonderful program that's dealing with all of this at WSU. This is the future. This is absolutely the future. So finally, our challenge, and I'm an educator, our challenge is how do we educate moving forward? We need to grow energy and emissions consciousness in a way that we've never done before. When I was coming through, that was not something you talked about. That was never an issue. Climate, emissions, no. Maybe we need new design goals and approaches for how we do what we know we need to do. I think there's also new ethics in this. Who do we work for? How do we do it? I know there's a typo in there. I saw it a while ago. I didn't have a chance to fix it. We need to think about new materials and construction methods. We can't be 20th century people anymore. We're in a new era. And as I said, I think ethics are going to be critical in all of this. Who do we work for? How do we do it? How do we ensure justice is centered in all of our work? So I'm going to leave this slide up with the image of what essentially is your all's future. You all are going to help be the ones that figure this out or not. How do we go from here to there and still do what we need to do? So, thank you all for listening, and I'll be glad to answer any questions. That's a lot of stuff, I understand. Questions, yeah. We need to be doing it tomorrow. 2050 is the Band-Aid approach. That gives us 27 years, and most of the people that are making these laws will be dead in 2050, so they're kicking it down the road. I've given versions of this talk that says, we need to do this now and take the consequences as they come. Politicians are like, yeah, give us 27 years until we can. No, there's no magic number of 2050. It's probably too long, to be blunt. Other questions? Excellent point. When life, seaweed, straw, when it grows, it's sucking CO2 into it. And then when you use it like a tree or straw or something like that, you put it into a building and it stays in there happily away from the atmosphere. So you're using CO2 to grow the thing, and then you are putting it into a box where it won't come out again until something else happens to it. So that is the sequestration of using wood. Trees grow. A trunk is nothing but CO2 in a sense. You put that wood that came out of that trunk into a building, it stays in there until that building is torn down or burns. And then, it goes back up in the atmosphere. But that's an excellent question. CO2 is important. CO2 is our friend in many ways, but it's also too much of it, not so much. Yeah, and injecting it into concrete and things like that, maybe. I don't know enough about it. But the idea is scale. We use cement right now like it's going out of style. If we were to be able to inject it, would we have it at the same scale or not? That's what I think. All of these challenges are simply ones of scale. We have everything we have now because we don't care about pollution. When we start caring about pollution, we're going to have a lot less of everything. But the challenges are going to be even more important. So what do? We got to get creative, right? So, good. Other questions? Yeah, you could, if you were the governor of Idaho, you could set up and go, hey, all the business in Washington that are getting ready to get squeezed, come over here and do business in our state. And then you could bring it back to Washington. Or Oregon could do that. There's nothing. Further, there's nothing that says when this starts impacting the price of gasoline, and it will, if you're living in Seattle and you're paying so much more than somebody in Portland or in Boise, that could really start getting people pissed off about this. Because it's going to cause, they're going to price gasoline out of existence. That's what's going to happen because gasoline is terrible. But if Oregon's not doing it and Idaho's not doing it, we're going to be okay. We'll just drive over to Moscow, right? So I think this is all great until the rubber hits the road. It's like, wait a minute, I'm all for this, but I got to pay more?
Are any drastic changes set to happen soon?
Yeah, that's the thing again for the 27 years. They're going to baby step their way into it. Like you won't notice, you haven't noticed, I'm sure that this is now the law. There's no price of, increase in gas right now or anything like that. The whole goal is, and I applaud our lawmakers for doing this. This is gutsy. The whole point of this is to ease our way into it, get used to it. We roll in electrified transport, and that takes some of the pressure off. And ideally, they start giving you tax rebates on electric bikes and things like that. And so they should take the pain out by giving you other options. We'll see about that. I think maybe in 5 or 6 years, we were out here and everybody else hadn't followed us, and we turn around and we're like, oh, we're out here by ourselves. What good did it do? Why should I, as a Washington citizen, have to pay more if nobody else in the world is doing this? I think Inslee is betting that the world is going in this direction, the United States as a whole, the world as a whole. Will that happen? I just hope I live long enough to see this, because every day I wake up, I'm like, oh, I can't wait to see what happens. It's like a soap opera. I can't wait to see what happens. If I make it to 2050, I'll be up there, but I can't wait. I got to see the last episode of that final season, right? And see what happens. But yeah, it could be in 4 or 5 years, like, why are we doing this and nobody else is doing it? Because Washington is a drop in the bucket of the global emissions. We put up 40 billion tons every year of pollution. Washington State does 100 million of that. It may be too late. We may have passed the tipping point. And I've been watching this for a long time now, and I keep thinking, the heat in Seattle, that's going to wake people up. The fires, the floods, the droughts. And we're all normalizing. What's weather, So it's going to be tough because we're comfortable, certainly in this country, with the way we are now. Yeah, that's where you start to see all of these little things like, well, I want electric cars for everybody. Well, no, you don't, not on this scale. I want electric bikes. Well, that's better, but there's still a emission thing so far. Wooden bikes would be awesome. Wooden electric bikes may be the dream. Where do we get the battery materials? So that's great though, because now we're just thinking of all these little systemic connections that we've never done before. So we're right at the beginning of this. We have to have a war on cars. There, I said it, it's on tape. We can't continue. Even if we weren't doing a lot of other things, the cars destroy living habitats for humans. They're deadly, they're terrible for breathing and children. But in this country, we spread everything out so far, that's gonna feel like pain. And I don't know how to get over that, but we need to do something about it because we've spread everything out. And now you have to have a car. You can't really survive. Now, some of y'all see me riding around campus and stuff like that. I can afford to do that, but other people can't. And so how do we deal with that? But certainly, as an urban planner, heat domes and rain bombs, we've got to begin undoing, depaving, softening, tearing out. The heat island effect amplifies a heat dome. So an urban area is hot anyway when the sun shines on it, but literally there's a weather phenomenon called a heat dome that Seattle saw, which they got what was Seattle's temperature? 112 degrees. The heat island effect would have made it hotter in a localized area. It can influence the weather, and then a heat dome is this climactic thing that settles over a region, making the heat dome even worse. So we've got to, and urban planning is my kind of thing, right? We've got to figure out how to soften, green. We've got to deal with rainstorms in ways that pipes can no longer handle, and that's freaking people out. We're no longer in that 20th century mindset of we can just engineer whatever we're facing. We've got to unlearn a lot of that and begin experimenting. Yeah, I think buildings need to become sponges. That's going to be a big part of it. That'll help the floods, but that could also help in a drought, right? So we got water laws. We got water laws that would prevent a lot of that. We got to start undoing a lot of those things. But yeah, I think buildings have a part of that too. Like cities need to be sponges, buildings need to be sponges. So buildings have got to do a lot of new things in addition to all the other things that they have been doing. Other questions? Anybody else? Yes. How do I get up every morning? A big part of it is I wish I was 40 years younger, because this is wonderful. You all have a challenge that nobody else has ever faced. That's a lot of pressure, but man, that's exciting too. There's no wrong way. You all can set the things. You don't have to come and learn the rote crap in the past that I had to learn. We're all learning this at the same time. You're just as valid as somebody who's been doing it like me for 40 years, right? We're all learning this. So yeah, I'm optimistic, but I hope I make it to the end of this just to see. If I made it there, I would be 86 years old. It's not impossible. But I'm just dying to know, how did we do? So, yes, be positive. This is your chance to make really the world a better place. So, all right. Thank y'all for listening.